Good morning.
Good morning, everyone.
And welcome to today's exciting webinar on gaining total control of LiDAR and point cloud data. My name is Dale Lutz.
And my name is Dmitry Bog.
And we're your hosts today for this exciting webinar. So a few words about us. I'm one of the two co-founders of SAFE. I've been around since the dawn of time here, and very excited to be able to share with you some of the great things that we think we've been up to on point cloud support in FME and things that I think will make you more productive.
And I'm here for 8 years, and I love playing with new things. And point cloud, maybe not as new as 3 years ago, but we have lots of new things to show.
That's right. And actually, I think, Dmitry, is this the third or fourth time we've done this webinar?
Yes, I think so. Yeah.
But we've completely revamped it. Dmitry has created a whole new set of demos. So this is all new for 2013.
Yeah, all new demos and twice as many as before.
Yes, so we better get right at it. We're joined this morning by our friends Dave and Dean, who are busy somewhere else in another room waiting to answer your questions. So don't be afraid to ask them and keep them nice and busy. So just a couple words about Safe Software. We're the company that makes the product called FME. We've been around since '93, and our mission is to take our customers' data and help them to move it from wherever it is to wherever they need it to be. And we do that by providing FME. FME is a product that now reads over 300 and some formats of a wide variety of data types, and lets you put that data wherever you want it to be. And with that, I think we'll open. We got so many demos. We want to get right to things this morning. So we're going to open with our first poll, which is, do you currently use FME for point cloud stuff? So we're going to launch that poll, and we'll see the results coming in. So the folks are voting right now. Quite a lot of folks that are using it. So if you are using it, for sure you'll want to stay till the end of the webinar, because that's when we're showing some of the most recent new things that I think are very powerful and interesting. And I think we have about, there we got 2/3, which is enough to, I think 2/3 is enough to change the Canadian Constitution, so we can probably close that there. We'll let it go another couple seconds, and we'll close that poll, and we'll share those results. So let's see. There's a lot of folks, 20% that use FME, but not for point cloud stuff, and a whole big swath that plan to do it later next year. That's the plurality. So I think they'll be well equipped to begin their point cloud journeys after today's webinar. What do you say, Dmitry?
Yes. So please stay tuned.
Yes, so FME sits in the middle between all these different data types, and that's a key thing when we're talking about point clouds. Point clouds are just one bubble in this kind of universe or solar system of FME, and while you can do many translations that involve only point clouds or transformations, the more interesting stuff happens when you combine point clouds with GIS or CAD, and you start to do interesting things. And several of our demonstrations today involve this integration or the combining aspect of point clouds.
Exactly. So, and we do those transformations in our graphic environment called Workbench, where we build these transformations. On the left side, you can see a couple of readers that can read all kinds of data. So in this example, you can see a LiDAR and a Raster. And then we transform these things with our transformers, these blue transformation units. And at the end, we can write to hundreds of formats that we support.
Yes, so that's an example of another integration right there.
Yeah, so these workspaces made in Workbench can be quite big and complex, as you can see here. So, and yes, let's begin with our first demo.
So, wow, Dmitry, you're going to make something from scratch? Is that what I'm told?
Yes.
Okay, so let's see. Oh, that doesn't look like it's from scratch.
That's no.
Okay.
So let me bring this Workbench environment to the screen and start building. So a customer of ours sent us a DGN file for a site where they plan some reconstruction project. So let's add a DGN file to Workbench. This DGN file represents just a boundary of the project.
Ah, a little shout out to our friends in Langley. I think this is Langley data, isn't it?
Yes, it is Langley.
My home city. So thanks.
So let's read it by levels by names.
Okay.
So we will see that this is our project boundary.
Okay.
So, and we have all kinds of data to provide this customer with point clouds and rasters. So let's add some E57 files.
Hey, there's a little something for our friends that like E57.
Yeah, this is a new format we added. So we have a couple of files here.
So these are point clouds.
Yes, they're point clouds.
So E57 is a standard, and we added support in FME 2013 for it.
And we also have some orthophoto, an image in ECW. So because we have 2 point clouds, let's first make just a single one with point cloud combiner transformer. Then we probably need some extra space around the project. So let's buffer our boundary with bufferer.
Okay. So you're typing in these transformers are coming up that are modifying the data as it flows through, I guess.
This is such a great capability in FME. I really love it.
Okay.
Well, but you have to know all the names of the transformers.
Yeah, that's the one thing. But you can learn them.
Yes. Then what is great about combining all kinds of data together, that we can somehow take, for example, colors from the ortho image and bring them to our point clouds.
Yes.
So for that, we have point cloud on raster component setter. I think that's the longest name we have.
Yeah, it's a powerful thing, but we should have called it the colorizer. And I see there's a question from one customer tuned in that's exactly why he's tuned into the webinar. So please, now you've seen your answer. I hope that customer stays to watch the rest, because they said that's exactly what they were looking for. So
yeah. Okay, that's great. And now our point clouds and our raster can be bigger than the customer needs. So let's clip them to this project boundary or buffered project boundary with a clipper transformer.
Okay.
So that will be our clipper, and we will send our point cloud as a clippy to the clipper. And now we can write it to board format, because MicroStation works with POD format, point tools format.
So we need to
add a point tools writer.
And I want to thank our Bentley friends for supplying us the ability to do that. Okay. So so this is setting up the output into the pod format, another LiDAR or point cloud format that's used by MicroStation now. Okay. So you've clipped out, so you've colorized and clipped.
Yeah, but here is the thing. Our image is 24-bit. So we have just 8 bits, so a number between 0 and 255 for each color, for red, green, and blue. But pod format needs colors in 16-bit per color. So we have to scale those colors to meet the standard that required by pod files. So for that, we need point cloud color scalar transformer.
Okay. Right, because sometimes some of these point clouds, the color is from 0 to 255, and sometimes we want it to go to the full 16. There we go.
Okay.
All right, so we've done a nice job of the pod.
Yeah, now, but we need some kind of overview of this project so that we can give it to
my mother, for example.
Yes, so that they can easily view it and understand what is going. So for the general public, for that, let's generate a surface.
Okay.
From the point cloud.
Okay.
And now we need
Or are you going to try to color the surface? You must have to set the tolerance for that surface.
Yes.
Oh, a very fine surface.
But we also need to clip our orthophoto.
Okay, you're going to do another clip.
Yes. To the same boundary.
So whenever you have two things coming out of one transformer, there's a copy of the data going there. So we've duplicated our clipper, and you've duplicated the image, but FME is very fast about doing that. And so now you've got a clipped image. What are you going to do with that?
I'm going to put it on top of the surface.
Oh, slap it onto the surface.
Yes. With appearance setter.
Okay.
Appearance, surface. And I would like to say that we need to do that from top view.
Okay.
And now I know that that area is pretty flat, so I think it would be nice if we scale it a little bit for better visibility, so we can add scalar transformer.
Okay.
Say, let's scale along Z by 2. And finally, we can add a writer which can be read by anyone. PDF 3D. This one.
Okay, so you're going to put out a 3D PDF.
Yes. Just change the background. So I think we are ready to run this thing.
Okay, wow. So we're going to be clipping out a chunk. We're going to be colorizing. We're making a surface. We're making a 3D PDF for writing pod. Dimitri, is that all going to work?
Well, let's hope it will. So it takes just a few seconds. We failed because...
Uh-oh. Did you...
Let me give another...
PDF must have the wrong directory.
Did I set it?
I don't remember you setting the directory for the PDF.
Sorry. Maybe I have to give another name.
And we wait with excitement as the PDF gets created. No, sir. I think there's something wrong with your directory. Or else you've got the PDF open already.
I don't see it open.
Let's just pick another directory for it.
Let's go to here.
Yeah. There we go. Project.pdf up there. So we'll run it and we'll take a look. So all of that stuff, how many times have we run this now? About 3 or 4 times?
That's the 3rd time.
Okay. So it's pretty fast to do all this. And here we go. Okay. And it's done. So I knew there's something wrong with that directory. So let's go up there where you put it. There's a project, and now there we go. There it is. Okay, so that's what we can send my mother of the project area that we're working on. And we can see that there's a little bit of terrain there at that campus. That's out in the top end of Langley University campus, I think. And that's good. Now, what about the pod file that you made?
Okay, for inspecting pod file, we can open MicroStation. That project boundary that we had at the beginning, open it, and here is that point cloud within MicroStation. So our customer now is ready to work with this data on reconstruction.
Okay. Well, that's pretty impressive, Dimitri.
So now let's return to our presentation.
Okay, so that was a bit of Dimitri's just going to calm down now. I don't know what was wrong with his directory there, but he'll be calm in a minute. But we just wanted to say a few words about LiDAR and point clouds and some of the challenges they typically present to customers. and in particular, volumes, it won't work. You have often billions of points that are being handled. You also have some challenges because as GIS professionals, we're often used to well-behaved 2.5D data where for a given X and Y, we only have one Z or Z value. In the case of point cloud, you may have multiple returns. You also, for any X and Y, may have a whole variety of different types of data that have been collected, intensity, colors, return numbers, or you might have only X, Y, and Z. So there's some interesting differences in the data model, and they can be overcome or useful to apply the point cloud to different kinds of situations. So unlike rasters, which are well behaved, you know where for a given X, Y, we have just a nice well-defined set of measurements. We like to say that point clouds are rasters gone wild. And so yes, we have said that. This is the 4th time we presented that slide, and it'll be retired after this presentation. We'll never show it again. But that's a nice way to think of it. So all the challenges you have with rasters, plus a whole host more when you're dealing with point clouds. But fortunately, we have a variety of solutions. And today we have even more solutions than ever. And so Dimitri will be walking us through all of them shortly.
Yeah, but let's begin with our second poll question. Which point cloud formats are you interested in?
Right, because one of the things we do have a solution for is translation. So this is always useful for us to understand where folks are interested in doing translations, where their data is starting from and going to. Wow, this is a fairly, I won't tip my hand, but there's a fairly dominant early leader here. So let's see where this goes. We'll wait a little bit longer. Okay, we're waiting to tip over into the next. Here we go. Wow, I'm actually quite surprised by these results. Very, very interesting. I'm going to close the poll there. Thank you all for your votes, and we'll share these results. And that's very interesting. Last one off to an early start, but still overwhelmingly dominant. Oh, did I not show the results? Yes, I did. So yeah, last is the dominant player. But look at E57. 11% of the people a year ago, it was a blip on the radar. And Oracle Point Cloud, very, very popular too. We're not showing any Oracle Point Cloud today, but FME does indeed use that. We were just talking to a customer yesterday that was doing that with great success. And quite a lot of folks, we can only have 5 choices. We really would have loved to split out Riegl, ZFS, or as we say in Canada, or ZFS, I'm sure everywhere else, or TerraScan, so we could break that apart. But good to see that there's a broad spectrum of formats being used, and we have solutions for all of you. So that's really quite interesting.
Yeah. So this is the list of point cloud formats that we support today, and this list is obviously will be bigger by next year, and you have the ability to combine or work as we already showed to work with all these formats like vector and raster together with point clouds. For LAS support, we support LASZ compression. It's a German technology where you can run your files, save your LAS files in a compressed form, and you can compare some numbers. These are for colored LAS files, so they're probably 2.5 times smaller, and even better numbers for intensity only point clouds. It's about 4 or 5 times. Sometimes it can be up to 8 times smaller files.
Yeah, that's a free bit of software made by our good friend Martin Eisenberg out in Germany, and thanks Martin for making that available to basically the whole community to use and benefit from, because when things are gigabytes in size, saving a gigabyte here or there, it starts to add up, and it can add up substantially. Again, go to lasdzip.org for more information, but the main thing from an FME point of view is it's just built in, and you just can read this anywhere we read a LAS file, and if you're writing, you just say to compress, and off you go.
We can, of course, we have data inspector application where you can view point clouds, and what is really good about data inspector that you can bring all those hundreds of formats that we can read together and inspect them together. Now we are going to talk about typical operations that we can do between reading and writing, and our poll question is about typical operations that you need.
All right, so let me go to the polls here, and let's launch the poll. So yeah, what kind of things? Again, a multiple choice poll. Okay, and the results are coming in. All right. So we'll let, again, very interesting stuff, a very high number that want to do feature extraction, and we do have some things to show them along that. So let me close the polls with a very good turnout and share those results. And there we see surfaces, again, very big. A lot of people looking for enrichment, and so that's some of our new demos are all around that.
Yes.
And tiling and clipping are always popular. There's some new features in there that we'll show. Feature extraction, lots of people wanting to do that. And so that's definitely an area that we can continue to push into. So thanks for those results. We'll let Dimitri carry on.
Okay, so of course we can reproject our point clouds in a few ways. For one of the vendors, it was crucial to have geocentric coordinate support and orthometric height. So we added it in 2012. So, and here is a nice illustration how we support geocentric coordinates. And that will be our second demo.
Okay, let's take a look at that. Because we do get some point clouds in geocentric.
Yes, yes.
It's a bit unusual to want to make geocentric, but that's what Dimitri's done here. So you got a JPEG.
Yeah, I have just a JPEG or the map of the world, and here I create just a rectangle representing the world. Then I add this JPEG as a texture to that rectangle, and then I make a point cloud from that, and here I reproject it to geocentric coordinates. Let me run this. And it will take, as this annotation says, about 22 seconds.
Okay. So we'll anxiously await that.
So, and here is our planet to scale in geocentric coordinates.
Wow.
And I have all the planets. I have Jupiter, I have Mars, Venus, I have our moon as point clouds.
Right.
Made with the same workspace.
So you can zoom in and out of that thing?
Yes.
Yeah, okay. So again, this is showing going to geocentric, but of course, if you have data that is already there, you can definitely make it into something a little more easy to use in a traditional environment.
And in FME 2013, we added a Blue Marble reprojection engine and a new transformer, BMG reprojector. I can bring the dialogue showing.
Yeah, let's just quickly show folks. This was a thing that we worked together with our friends at Blue Marble, and while FME does have quite a comprehensive projection support, the Blue Marble guys are often the gold standard for many customers, and so they integrated into our universe. So this is their dialogue inside of FME, and they can all of their very impressive wealth of coordinate systems can be accessed directly from there, including all the 3D kinds of shifts as well that can be done. So that's the Blue Marble stuff. To make that work, you have to have some stuff from Blue Marble and FME, but then it does work happily together. I won't break into my Sonny and Cher song as I have done in the past,
though. We can, the next slide, we can tile the point clouds. One of the reason for tiling is obvious, for example, smaller pieces for delivery of them. But another thing I found is very useful, that point clouds, when you tile them, you can speed up your processing time by organizing a few processes in parallel. Another interesting option here we added in 2013 is a seed point. So if you have your tiles 500 by 500, you don't have to, your edges of your tiles don't have to end with 500 or 30. So you can set any point for your grid to go through.
Right. And that's a big deal, because sometimes people want the tiles aligned to certain coordinates.
Now, clipping, just any arbitrary boundary will clip your point cloud. And here I would like to mention that we added parallel processing. So you can, if you have multiple clippers, you can organize multiple processes and run them simultaneously. But I would recommend going to FMEpedia and read the article about parallel processing before you use this capability.
We'll have a link on that at the end here.
Yeah. So we try to clip really huge point clouds, over 1 billion points, 40 gigabyte single file, and within, say, 3 to 4 hours, you can get manageable pieces out of such a huge point cloud.
Yes. So that one of the customers asked, is there any practical limit on the size of point cloud files that we deal with?
Well, it is not that easy to deal with the 40 gigabyte files.
Yes.
So it makes sense to reduce the size to 200, 400 megabytes.
Yeah, but FME itself is fine with
yes,
processing
it just
these things.
Takes time.
It just takes time. So there's no, I think that we actually did run into some issues for a while with the LAS format itself, with the files getting too large for the LAS format to handle. And so that was briefly an issue with, but anyway, we got past that on some platforms. So actually, yes, there is no practical limit, although practically you don't want to deal with files that are just individually so massive because you can hardly transport them around.
Now, we have cubic clipping. If you supply solids as clippers, you can easily clip your point clouds in 3D. Here is an example where I built stacks of small 1 meter high boxes and then analyze how many points I have per each box, and setting a certain threshold, I can separate surface from the rest of the point. So here is an example how I clean everything from trees, street lights, buildings. It is not a true feature extraction, but in some flat areas that may work quite well. We can thin point clouds. If you have massive point clouds or you combine lots of point clouds together, you need an overview. You can thin the point cloud with some options. And we are working on some more advanced thinning options for future FME versions. We can build surfaces. And we already saw that in our first demo. And again, we have here the ability to split if you have multiple LAS files, for example, you can run them in parallel to generate multiple surfaces.
Right. So the parallel processing can help the speed, and again, we'll have the link at the end. But again, one customer was asking, how do they make 3D models out of point clouds? And so here's an example. This will do really a 2.5D. It's meant for creating surfaces of topography, that sort of thing.
Yeah.
It isn't meant for taking a scan of a building that's taken from the ground and building a 3D model there. We don't do
that. We can combine point clouds. So we already saw that in our first demo, but we also can combine just about any geometry to a point cloud. Here is a few examples. This image represents Germany with some church in it. It was made from 2 rasters, one RGB, one DEM, and a SketchUp model, and combined into a point cloud. This is augmented reality, where we added these 2 cars which weren't originally there. And another example, I added these trees from a SketchUp model, and as you can see, we also used the textures that the original tree had to make it into point cloud colors.
Yes, so that's really quite impressive, because it means you can augment point clouds with SketchUp models or other 3D models you might have. and create new point clouds. Sometimes point cloud visualization is the tool you want to do, and so FME makes it very easy to do these sorts of things. The opposite of feature extraction, feature injection, perhaps.
Now we can split point clouds. Some obvious splitting is.
Yes, one customer was asking, do we use clipping to make bare earth models, but actually splitting would be a better way and take the last return.
Yeah, if you have classification or returns, you can split by those components, or we also added some interesting possibilities with splitting by color or by intensity. For example, we can extract some road marking from the road surface. Here, let's try our third demo to extract yellow color from the road.
Okay, so we got a point cloud, color point cloud. This is actually customer situation, wasn't it?
Yes, that was customer-driven request. So we got that request and thought, why couldn't we?
Right. So the main thing is the point cloud splitter.
Yeah. So we extract yellowish points from the point cloud, and then with some processing, with building a concave hull, and some cleaning, we get the results. So in this situation, we deal, I think, with 60 megabyte file, and it took just a few seconds.
Okay.
So let me show you. I can turn off everything. So here's our point cloud, and here is the extracted feature.
The center line.
The center line.
Can you just show only the center line? There we go. Oh, that's pretty good. It doesn't need to be repainted.
Okay, now I tried that on a bigger example. So here is another example of extracting yellow color, and here I extract white. So it is all possible. Here I have to analyze the shape of the features extracted, because we have lots of white, but it is all possible. We already showed this point cloud and raster component setter. It has such a long name because we can set not only color, but color is probably the most popular one.
Right, so you can set intensity, you could set other components.
Classification, if you have a raster that has classes there, yes, you can transfer them to your point cloud.
Right, and this combined with the expression evaluator would let you could even set elevations or make other kinds of results.
Yeah, lots of interesting.
So again, some scenes from Langley. The Langley folks had us do that. Thanks very much, Langley friends.
We can inspect point clouds, compare the header versus real actual points, and extract all the components that we have there, enforce true extents, and retrieve mean and max components. At the end, I will show another demo using this transformer, but in general case, that's what you would see before and after when you match your header of, for example, a LAS file with the actual content of the file.
Right.
We have some solutions for ArcGIS. We can generate LASD files, which allow you to open LAS file collections in ArcGIS.
Right, and that streamlines workflows for those folks that are going to be using point clouds afterwards in ArcGIS. So you can just flip that switch on in the Workbench, and when you run your translation, you'll automatically have the LASD that lets you instantly view an ArcGIS.
So
there it is.
That was another customer-driven request to make some profiles or slices, profiles of certain width of point clouds. We used to run this demo before, but now we show all new demos. So here's just the results.
It is impressive, and so the basic idea is, given a line as input and a point cloud, we will generate for you a bunch of slices along that line, perpendicular to that line, so you can view those for your work and for further analysis.
So, and now something new.
Yes.
Calculations per point. We added a point cloud expression evaluator. Before FME 2013, my favorite transformer was Raster expression evaluator, but now I have this transformer to play with.
Yes.
And let's switch to our next demo.
Yes. So, okay, oh, this is one where we're going to simulate a flood very quickly by doing some calculations on each point within the point cloud.
Yes, here we apply some expressions to color components. As you can see, you can change any component of the point cloud, but here we set flooding level as a parameter. We will show that, and then change a little bit the color. So if a point is below that flood level, then decrease red and green components and increase blue. Otherwise, keep it as is.
Right.
So if you run it by pressing Control R, we can change it to say 250 feet and run it. So and now each point will pass through this these expressions. I can.
So that was what 4.1 million points there, I think. Yeah.
I think. Yeah. So this is our original.
I was going to say it didn't look flooded to me, Dimitri.
Yes. And now we have what we have after that.
Okay, there it comes in, and it's looking bluish.
Right. So if you get some forecast that water will raise to this level, you can predict what you should do.
So it's a very, very fast way, basically accurate way to model changes in that way. And that's by doing point-by-point math. Now, Dimitri, I want to go off-roading here a little bit. We are doing okay for time, and I'd like to make an example, and this one is a little salute out to our friends at Bohannon Houston, who at some conference years ago suggested we do this. So gave me the suggestion. So what I've got is a polygon. So you want to just drag that in. I made a polygon last night in Spatial Light that was, so yeah, go for Spatial Light. And oh, you got to type the whole thing probably. Yeah, there I saw it. Spatial, that's too many ITE. Spatial ITE. There we go.
Okay.
Spatial Light, new format in FME 2013.
Yeah, never used it.
Okay, well, we'll find out how it works. So the lake leveler, there we go, that one. Hit the parameters, look at the table list. We should have one table in there, which is our lake. We'll say okay to that, and we'll add that. So okay all the way. And now let's also add that E57 input data. So we have to change your format.
Right. Right.
So change it to E57. So we got a point cloud, and the idea here, in a minute, we'll pop up and look. So what I want to do actually is on the lake, just right-click and say Inspect, all the way down there, and we'll take a look at this lake. And let's see, Spatial Light. That's a bad sign, Dimitri. Okay, well, we'll go with the fact that I don't know what happened there, but let's just go and add an inspector transformer to this. Okay, inspector, connect inspector, and go ahead and run that. We should see that there's one feature. Yes, there we go. And it has an attribute called elevation. So we know that the elevation within that lake is 3.2 meters. It's pretty close to sea level here in Vancouver area. And so now what we want to do is take and we'll go into this guy and attach a clipper. So we're going to clip the point cloud, and oops, the clip E is the point cloud, the clipper is the lake. And now I want to go in the properties of the clipper, and I want to say to transfer the attributes. Yes, that's good. And so now we've got the part of the point cloud that's inside and the part that's outside. So now let's connect visualizers to all this. We can right-click and say connect inspectors. Yeah, to those two. And we won't run it just yet because we'll leave that. And now let's put down our point cloud expression evaluator, the PCEE. And let's attach the guys who are inside, and we'll pop that up. And what we're going to do is the component, we're going to change the Z. We're going to flatten this lake, and we're going to pop up the expression. And if we just drag out the clipped elevation, there we did, and that's been set like that. And now it should, now we'll do a point cloud combiner after this, PCC, point cloud combiner. So now we're going to bring back the one we just modified with the one that was outside and take a look at that result. All right.
And
so
let me maybe drop a point cloud property extractor here.
Right, okay, that's going to tell us what the mins and max were or something?
Yes.
Okay. Is it all okay?
We just don't need all this.
Okay. All right, so let's run this. So what we're doing is combining some knowledge of the topography with our point cloud. So if we, let's take a look, only the things that were inside. That was the original data.
So, and now we can see that the elevation of the points within a, well,
in the lake.
Yes, in a flat area, change from 2.5 meters to almost 5 meters, which is obviously wrong.
Yes. So now afterwards, when we combine the whole thing, there it is. And if we go in there and look at some of the points, just go and get the info on some of them, they should all be at 3.2.
Right. We have to switch to 3D mode.
Okay, here we go. Down in there. And let's move that a little bit so we can see. Oh, we're not in the lake. We've got to flip on the lake so that we know where we're working. Okay. Yeah, there it is. So we can see that we've leveled it all. So anyway, I threw that in, friends at Bohannon Houston. That was something that you asked for a long time ago, and it works just pretty quickly. And you saw it's very, very simple to basically combine information from vector features into the point cloud. So that's the end of my interruption in the demo, Dimitri. Go ahead.
Yeah, we also have another transformer similar to this one, which is point cloud filter, where based on some expressions, you can get multiple point clouds. And that will be our 5th demo.
Okay.
This time we read Riegl or Riegl format, and we try to extract road signs based on their intensity. We all know how very reflective those road signs are. And in this situation, we deal with almost 1 gigabyte of data.
So while it's running, can we take a look at the filter expressions?
Yes, so
this is like the splitter that we showed before, except we give you, wow, that was pretty fast. Anyway, we give you a complete vocabulary to write arbitrarily complex expressions to write your own filters.
So here I take intensity which is higher than 0, because in Riegl the intensities can go into negative values, and just take a short portion of the highway between those x coordinates, and let's inspect the results.
Okay, so this is the whole thing we're seeing still. Okay, wow. So the red stuff is the signs you lifted out?
Yes.
Right. And so that was done just by filtering with a custom filter expression?
Yes, by intensity.
Yes. Okay. Again, very powerful. Really, you're limited only by your imagination between the point cloud expression evaluator and the point cloud filter. Being able to operate on a point-by-point basis on the data in an extremely fast way opens up a lot of possibilities.
Now, here you can see some numbers with tiling and clipping, but I made them on my old machine, so maybe we can do better today. These numbers are pretty old, about 2 years old.
Right, so we should run them again.
And here is the link to parallel processing article on FMEpedia.
Yes.
Where you can read how you can organize those processes on your machine.
You want to click on it, Dimitri? Let's take a peek. So there it is, a number of stories about reusing the parallel processing for different things, and here he shows how you can make surfaces much more quickly.
Yes.
By using the power of the parallel processing.
And here I give some numbers that you can compare how beneficial parallel processing can be.
Yes, so that's just part of FME, and it's a switch you throw, and Dimitri's article shows you how that works.
So, and now our last demo.
Our last Is it our last demo or our last demo? Maybe it's both. Okay, yes. We're going back to university here, and this time we're making a 3D model of sorts. So you want to talk us through this, Dimitri?
Well, here point clouds play maybe a smaller role, but maybe a few interesting things that I do here. We already talked about coloring. Here I use Clipper and geometry extractor together to show some interesting trick. I extract geometries from buildings from a shapefile, and then when I clip with these buildings the point cloud, I get point clouds which have all the attributes of the buildings.
So you're clipping, using every building as a clipper, doing a multiple clip, and then
yes,
you're getting...
I get as many point clouds as I had buildings.
Right, that you've cut out.
And each point cloud knows everything what the building knew about itself.
Right,
including, yes, including its own geometry. So now I can extract min and max values for the point cloud.
Yes.
And then replace the point cloud geometry with building geometry.
And now you're going to...
And this gives me the elevation to which I should elevate my building footprint.
Right, so the base, you lift the base
yes.
up.
Then I just build walls and roof. And for roofs, I use our image to add the clipped orthos to the top of the roofs as textures.
You also clipped the buildings out of the ortho.
Yes, so here's another clipper.
Yes. So we got basically a piece of image for every building and a point cloud for every building, and then you're slapping them together, and you must be making some walls. Do you have any imagery for the walls?
Unfortunately not, I simply set color. But if you have images for your buildings, then it is...
You could paste them on too. We did an example like that.
Yes, we have that, yeah.
So you're going to run this thing?
Yes.
So we're going to basically make a 3D model-ish of the campus. We are going to end up with 3D buildings having been extruded to their scanned heights.
Yep.
Okay. It's thinking. So all 131 clippers are done. Now we're clipping some more. And it's done. We're just popping up the answer. Of course, it could be routed to ArcGIS or anywhere else. And so what do you got there?
So the point cloud, it works pretty well for vegetation to stay within point cloud. It gives it very nice, realistic look, I think. Yeah. And the buildings with the roofs taken from the ortho image.
Yeah, they look good.
And walls just colored brick red.
It's a whole brick. It's like we're from Eastern Canada. Brick buildings everywhere. Okay. So now can you flip off the point cloud just so we can see the buildings floating there in space? There they are. Okay, so that's our extruded 3D buildings. Okay, that's pretty impressive.
Yes, so here we end with just point cloud demos, but we also use point clouds with some unconventional purposes.
Okay, so this is sort of graduate level. A little bit quirky uses of point cloud. So this is the next material is sort of bonus.
Yes, yeah. Lots of our customers ask whether we could make raster histograms, and we really would like to work on that, and I believe eventually we will have them. But for now, we don't have any raster histogrammers transformers, so I made a workspace, not a very complex one, which makes a nice histogram. Basically, it just splits the point cloud into thin 1 meter high point clouds, and then we just count how many points per each point cloud we have and build a diagram with Google.
Wow. Okay.
With Google, how is it called?
Google Charts.
Google Charts. Yes.
Yes. Google Charts API.
Should we run this?
Yeah. If you have it handy.
Yes, I do. Extra one.
Extra bonus. So probably we wouldn't recommend people do this, but it is an example to make you think about the kind of things you can do. So Dimitri basically splits. The key thing is to, first of all, turn the raster into a point cloud, which is easily done with that point cloud combiner, and then to split it into a different point cloud for every elevation value.
And we can check this. Should we show this in...
Yeah, let's take a look at that in the data inspector. So that's a CSV file, and that's something a little bit new in FME 2013. Is we've got field names there. We say OK. It'll run, and then we can bring, look at that, we have a table view now. So that's a very nice thing about FME 2013, being able to deal with non-spatial data in that way. And so there we get basically the count of the number of points for every elevation. Yeah. Okay, so that's one non-standard odd use of point clouds, but maybe will get you thinking about some other things you might be able to do. And this one here is pretty wild, Dimitri.
Just a couple of weeks ago, a customer asked whether we could split or clip any arbitrary polygon into pieces of equal areas. So, and with some thought, I was able to do that. So within 5%, we made that possible.
It is, yeah. So it's
I can open that workspace and show you the intermediate result, the point cloud.
And so this is because inside of one transformer, there's the ability to create point clouds out of area features. And which one is that? This one. So the point cloud cursor, we're feeding it an area we want a point cloud out. And so then the key thing is that top parameter that says output geometry, spatially equal areas for multi-points. And that does the right thing.
Is it running?
So it's basically generating points, and then you must fit a convex hull or a concave hull.
I can turn off areas, and you can see these point clouds.
Right. So it made point clouds, sprayed them into the area, each point cloud covering the same area, and then you just fit a boundary around them.
Yes. Yes. The rest was just cleaning those point clouds, making
so
polygons.
Again, pretty unusual use. We probably don't know that you would necessarily use that directly, but again, may spur some creative juices and some creative thinking. All right. So just to wrap up, I hope you've enjoyed this tour through the point cloud functionality of FME, and I hope that several of these capabilities are things you could apply to make your workflows and your work get done quicker and more easily. We say here that FME can help put your point cloud tiger back in its cage. I'm reminded by my friend Gene Rowe when I first showed him this a few years ago from LiDAR News. He said to me afterwards, point clouds used to have power over the people. Now with FME, people can have power over their point clouds. And I think we've added a few new capabilities that can certainly help you to tame your point clouds in the weeks and months ahead, especially the 24-25% of you that haven't used FME yet on point clouds but plan to during this year. We really hope that you will find a great benefit from that. So we've got, just before we wrap up, we may look at a couple of questions and answers here in the last couple of minutes, but just want to remind you that Dimitri and I will be back 1 week from now, same time, same place, but with better headsets. I know many of you had troubles with our audio. We experimented with a new technique today that I think is better than before, but we can still do better. We will be back with the best headsets ever next week at this time and showing off the partnership we've done with MapText, the label people, generating labels through FME in a variety of ways automatically. Would you say they're cartographic, Dimitri?
Yes.
Wow, and Dimitri is a cartographer, so it's hard to get that out of him. So showing off how MapText technology inside of FME combined can let you make labels for a wide variety of output formats, including the CAD formats, MicroStation, AutoCAD,
GIS, ArcGIS, MapInfo,
and GeoMedia even, and of course even out to rasters.
Yes.
So very interesting and very powerful labeling going to be shown next week. And then the week after that, Dawn and I will be here to talk about all things non-spatial. So we're going to be looking at CSVs and Excel files and stuff like that that people do with FME. And if you want to replay this recording, all of the webinars we've ever made are recorded and they're put online. And this one will be as well. And those of you that want to relive some of the fine moments of this webinar, like when we couldn't figure out why our PDF wouldn't write out, you can watch that again and again because we will put that online. And maybe we'll even have it in slow motion. for people to relive. So thanks very much for tuning in. I think we have one more question to ask the fine folks at home. And let me just say that. We've moved to offering folks free training if you come to our webinars. And so if you want more information on that, please answer the poll here and we will get back to you with information on that. I think there's a variety of training classes coming up fairly soon, and we can definitely get you registered into that. So thanks very much for your interest. A lot of you very interested in that, so thank you so much. So what else do we have, Dimitri? We've done that. Oh yeah, okay, we're going to send you an email again with the links to the recordings. And now I'm just going to move over here, and I think we'll just we got about 5 minutes left to spend with our fine friends. And so let me bring up, if I can, a list of the questions. And people asking lots of interesting things. Looks like we got a lot of interesting feedback. Let's see. People are asking, are they going to have access to these workspaces? And the answer is yes.
Yes. Well, some of the data sets are really huge. I'm not sure about the biggest one.
We might not be able to provide you the data. Also, I think some of the data is from our friends in Langley, and we need permission to give that out. But certainly all of the workspaces we had today, we will be pleased to give you.
Yes, the workspaces, yes, for sure.
Yes. And somebody else asked, can these transformations be pushed to FME server? That is a great question, because we can take the things Dimitri did and hit a button, and if you have FME server, suddenly these things become a web service that can be pointed at other data, run by anybody with access to a web browser and the site hosting it. You can have these be scheduled. You can do things so that when a new LiDAR file arrives in a directory, it is automatically processed, picked up, cut up into pieces, reprojected, and written out, ready for ArcGIS to use. These kinds of things, these automations are all possible with FME server, and FME server is very well suited for point cloud things, because often you're dealing with very, very large data volumes. You don't want to tie up your desktop all day long while you're working on this. So that was a great question. So someone else was excited about LASDs. Yes, we are very, very much excited about that too. Oh, one person says they can't output a LASD. You do have to have ArcGIS handy. You need an ArcObjects license on your computer in order for us to write out a LASD. So we're sorry about that, but that's all we can do right now. If ArcGIS or Esri folks make the LASD format open and public, then of course you wouldn't need that. But until then, sorry, you do need to have ArcGIS handy. So Dimitri, any ideas about detecting break lines automatically? I think we can't probably do that yet.
No, we cannot.
But that's an interesting kind of feature extraction. The person wants to extract the vertices of triangles in a tin layer. And that's actually, I think, pretty easy to do.
Yes. We output all the vertices separately, and then just we can extract coordinates and save them as a text file.
Right.
Or redirect them to shapefile.
Right. Let's see. Different projection questions. And so I think we covered that off quite well. And let's see, anything else? Extracting buildings and vegetations. So again, right now, it's kind of a, not quite a manual process, but you do have to create your expressions somewhat manually to figure out the thresholds you would want to use for classification. But we do provide you a very rich and powerful ability to write arbitrary filters that combine many, many aspects of the point cloud in the same filter.
Well, if you can bring, I don't think FME is a feature extraction tool, but by enriching your data sets, you can achieve some results, in some situations.
Yes.
So I would be cautious about saying that we can easily extract features.
Say it easily, but we can at least do some pre-processing that might make that simpler further down. So that would be the way. We'd be part of a good good workflow. So I think that we had people asking if we can add color to point clouds, and yes, we definitely can. And one person was surprised by the workflow. So the reason that we have the workflow that we do is so you create these transformations once and then run them over and over again against many, many different inputs. So it is true that you don't really define the workflow visually from the perspective of getting instant feedback as to what's going on, although often people do create part of a transformation, run it, see the results, go and iterate that way. But in the end, what you have is something that can be run over and over again on different inputs. And actually, Dimitri, one last thing before we sign off. Can you show them in your Workbench that there's a command line? Things. Anyway, I think we're out of time, so thanks so much for all the good questions. Thank you, Dimitri, for all the great demos. Thanks to you, our producers, Roger and Stephanie, and our questions and answers people, Dave and Dean. It's always fun showing FME. We really appreciate you tuning in, all of you at home there. And thanks very much again, and we'll see you in a week when we're doing labels.
Thank you, everyone, for tuning in.